Welcome to Lab M-3, Static Forces and Moments. The objective of this lab is to check experimentally the conditions for the equilibrium of a rigid body. You'll be using a derrick assembly in this lab, a knife edge to locate the center of gravity of the derrick, slotted weights and weight hangers. Here is the derrick as you will eventually set it up in the lab. There is a level mounted on the top of the derrick to check when it's horizontal. For an object to be in equilibrium, two conditions have to hold. First, the vector sum of external forces should be zero. Second, the sum of torques due to all the external forces about any axis must also be zero. Thus, the forces in both the x and the y direction should sum to zero. As all the forces except for the force exerted by the pivot are either along the x or the y axis, you can easily get the torques about the pivot. A horizontal force will be multiplied with the vertical distance from the pivot and vice versa. The torques that you get should also sum up to zero. Begin by placing a load of about 2 kgs for M2. Then determine the weight M3 required to hold the derrick in equilibrium with the level horizontal. You can start by adding larger weights and then resetting the derrick to the center to check whether it is balanced or not. Remove or add weights to M3 as required. After that, accurately weigh the derrick using the triple beam balance. And also locate the position of center of gravity of the derrick. With all the distances and forces for the balanced derrick known, you can calculate how accurately the equilibrium conditions are satisfied about the pivot point. Now that you know the force exerted by the pivot on the derrick, you can check that the torques again sum to zero about any other point. To get the uncertainty in M3, you have to find the minimum amount of weight which can be added or removed from M3 without disturbing the equilibrium of the derrick. The weight should be such that if we increase it ever so slightly, then the removal won't maintain the equilibrium. While doing the lab, you would want to make sure that the derrick does not rub against the sides of the collar. Also, remember to set up the string such that it doesn't rub against the orange bracket over here. In the end, you should be able to determine the effect of frictional forces on the equilibrium and how well were the equilibrium conditions satisfied.